Morning all. Today we about counter. Start. Is it visible? Right? Is my screen visible? Yes. So we'll see this big counter today. Okay. So we'll see about counters today. Right. So what is counter? Basically, it is called a digital counter, which is used to count, right? Which is used to count. What is used in this is flip flop, right? Flip flop is used to create or to build a counter, right? Which type of flip flop? Basically, T type of flip flop, toggle flip flop or T flip flop is used to create a counter. What it counts actually? It counts clock pulses, right? So digital counter is to count what it counts. It counts clock pulses. Whatever clock pulses you pass to the counter in response to those clock pulses, the counter is filled with some digital value, right? So this is basically a counter. So basically it counts the clock pulses which are passed to this, right? So there are oh, sorry. There are two types of uh, counters: positive age triggered and negative age triggered, right? So it is basically on clock signal, right? And a type of counters are synchronous counter and asynchronous counter, asynchronous or ripple counter, right? So we'll start with first positive age triggering. What is actually positive age triggering and negative age triggering, right? So if suppose this is my clock signal, right? When it starts counting on when the value becomes 0 to 1 or high state, right? In that case, such type of counters are called positive age trigger. That means it start counting on this, right? If this is 1, it starts counting on positive age trigger. Such type of counters are called positive age triggered counter. And what is negative age triggered counter? The counters basically start counting when signal becomes low or it start converting, from 1 to 0, right? At that moment, such type of or basically it starts counting on negative age. This is called negative age triggered counter, right? So this is a basic difference. Now, how it shows there on flip flop. If it is positive age triggered, then it shows with this line and triangular shape of clockwise. And when it is a negative age triggered, it shows like bubble is added with this triangular and line shape. This is a clock signal. So this is negative age triggered flip flops, and this is positive age triggered flip flop, which shows there in flip flops, right? So this is basically a type of flip flop. You can say positive age triggered flip flop, negative age triggered flip flop, and again on based on clock signal, it is called as synchronous and asynchronous, right? What is synchronous counter? uh, Clock is applied directly to all flip flops. In that case, it is called synchronous counter. And what is a synchronous counter? A synchronous counter is an arrangement wherein clock signal is applied to first flip flop, and to remaining flip flop, whatever output of previous flip flop is assigned as a clock input to second flip flop, right? So this is what a arrangement given in asynchronous counter. Which flip flops are used? Basically, toggle flip flop or T flip flop are used. Internally, T flip flop are JK flip flop with logic 1, right? With logic 1 means logic 1 is applied to J and K, right? This is basically called a T flip flop. So till now, is it clear what is counter, how it classified and positive agent, negative agent, synchronous or synchronous? इथपर्यंत क्लिअर झालं का? So this is about intro of synchronous and asynchronous. Now we'll see difference between asynchronous and synchronous. Now, what is asynchronous or a ripple counter and synchronous counter? Wherein this is, if this is my flip flop, right? In that case, the arrangement wherein clock signal directly is applied to first flip flop, and output of first flip flop is assigned as clock signal to next input, and such type of arrangement of flip flops is called asynchronous flip flops, wherein in synchronous flip flop arrangements are different, but clock signals are applied simultaneously to each and every flip flop, right? This is basically a, difference in between synchronous and asynchronous, right? In this, clock signal are not simultaneously applied, but in synchronous clock signals is simultaneously applied. Now, this about design. This design is very much simple, right? Now you'll get to know this thing when I show you the design of asynchronous flip flop, right? And design wise, this is complex. Synchronous is complex. That means you need to decide about design. You need to follow so many steps to just to design a counter, right? You need to follow so many steps, and after that, you are get to know what is my input for this flip flop or counter, and then you connect such counters. You follow those steps, then only your design of synchronous counter is complete. Whereas in case of asynchronous counter, The design is simple. What you need to do, you need to apply a clock signal as it is to first flip flop, and then whatever output of that flip flop is assigned to next stage, right? As a clock. So this is basically a simple design. Now, what is a asynchronous drawback of asynchronous flip-flop is propagation is slow. That means propagation is slow, or you can say speed is slow. Why? Because you are applying uh, output of one of previous flip-flop to next flip-flop. In that case, as and when first activate, then only second will activate. So at second clock pulse, the second flip-flop will activate. So in that case, speed is somewhat slow, right? So if you calculate a propagation delay of synchronous, or if you calculate a speed of this synchronous counter, in that case, clock signal is applied directly to all flip-flop simultaneously. In that case, the propagation delay is basically minimum than synchronous flip-flop, and obviously speed is faster than asynchronous flip-flop, right? So this is basically a difference in between synchronous and asynchronous flip-flop. Till now it is clear. हे कळलं का? Okay. Again, there are few classifications added in between, which are applicable to both the counters, right? It is applicable to both the counters. What does that mean? There are again counters available, up counters and down counters, and you say up, down counter, right? So what is up counter is it counts in upward direction. That means 0, 1, 2, 3 up to n, right? What is down counter? It counts from higher range to 0, right? This is basically up down counter. Sorry, down counter. And in up down counter, you can count in both ways. In upward direction, in downward direction, it has a mode. That mode sets whether it counts in up mode or an down, right? So this is basically up down counter. Then you may say that up counters are ripple up counter, ripple down counter, or asynchronous down counter, and ripple up down counter. You also may say that it's synchronous up counter, then synchronous down counter, and then synchronous up down counter. So you classified again this fact into asynchronous up counter, synchronous up counter, asynchronous down counter, synchronous down counter, asynchronous up down counter, and synchronous up down counter. Right. So those of synchronous and asynchronous is again classified into such way. Right. So up counter basically counts in upward direction, down counter basically the counts in downward direction. Up down counter has its mode. You set mode to up counter or down counter, right? So this is basically called type of um, counters, right? Then again about you know uh, modulus. What is modulus of counter? So before modulus, we'll see a state, right? So what is state? The counter if a counter counts to each stage of those things or clock pulse, then that stages are called state of counter, right? State of counter, that means uh, the each and every count which is present on that counter or which passes, the counter passes from each and every stage, and that stage is referred as state of counter, right? And if how many states that counter follows, right? That means modulus of counter. How many states that counter gone through is called modulus of counter, right? If I say my counter is mod 6 counter, then it will start counting from 0 and it will count totally 6 stages, or it will pass to totally pass from totally 6 stages and count that many things, and it will stop over there, right? Even though if you say that it is, it requires flip flop. How many flip flop it requires? It depends on your counting. If you want to count, up to 4, then it has that many combinations. So flip flops are required. 2 flip flops are required there. So based on counting, you can decide your flip flops there, right? So this is basically called a, or modulus is basically called a state of counter. How many states from which that counter is gone through is basically referred as mod of counter, modulus of counter. If I say mod 10, then it will count total 10, or it will pass from total 10 states, right? It will count from 0 to 9, right? This is what is the modulus of counter, right? So this is about, introduction of counters and what all types are present over there. इथपर्यंत क्लिअर झालं का? इथपर्यंत क्लिअर झालं का? हे कळलं का? मॉड्युलस वगैरे. Okay. Okay. So we'll see now two bit asynchronous or ripple counter, right? Two bit asynchronous ripple counters with negative is triggering and positive is triggering, and this is up counter, right? So we'll see two bits negative up counter, right? Negative is triggered up counter for 2 bit. If it is 2 bit, it requires 2 flip flop, right? Those flip flops are T flip flops. That means it is internally JK flip flop, right? JK flip flop are connected to JK flip flop connected to logic one, right? That is what is a T flip flop, right? Then this is my Q and Q complement, right? So if suppose I draw like this for clock signal, then this is negative age triggered flip-flop, right? If my counter counts in upward direction, that means I need to connect Q to next clock pulse, right? This is what my zero, J1, J1 to complement 1, J0, Q0 to complement 0, right? So this is how a negative is triggered flip-flop was right? So in this counting, how actually counting starts, that we'll see. Okay. So initially, those flip-flops, right? That means flip-flop 0 and flip-flop 1 are at 0, 0. When you apply clock pulse to this flip-flop becomes 1, right? And this is 0. When you apply first clock pulse, this is 1, this is 0. So when you apply a second clock pulse to it, basically it becomes, it is 0. So output on this is 1 in initial stage. Whatever is there is toggled, so 1 to 0, but output initially is 1. So clock pulse is applied to this second flip-flop and it again toggles from 0 to 1, right? So in that case, it becomes 1 and 0, right? Here it is 1 as it is. Then you apply a clock pulse at that moment, it toggles, right? So it is, this is 0, so Q is also 0 at that moment, right? So if you apply clock pulse, it toggles from 0 to 1. And here it is 0. So you cannot apply clock pulse to second flip flop. So it becomes it rather it keeps as it is, right? So it is 1 1, right? When you apply next clock pulse to it, here it is 1, so 1 is there. So clock pulse is applied, it toggles again, it becomes 1 2 0. At that moment, at Q1, 1 is present, so clock pulse is again applied to this flip-flop and this flip-flop becomes 1 2 0. So it comes at initial stage. So it start counting from 1 0, and next is 1 2 3, and again comes to 0. This is how counter works at negative age trigger. हे समजलं का कसं काउंट करतं कसं काउंट करतं समजलं okay so what change is that positive is triggering is फक्त हे असंच राहणार आहे पॉझिटिव्ह एज ट्रिगरिंगला हा असं साईन येईल क्लॉक सिग्नलला अँड यू बेसिकली अप्लाय Q complement to clock signal, right? Why? Because it is positive is triggered, right? So हा basic difference आहे up counter मध्ये हा negative is triggered counter up counter आणि हा positive is triggered up counter याचे एक्सप्लेनेशन तुम्ही चेक करा बुक मध्ये सेम आहेत ट्रिगरिंग फक्त वेगळं आहे Now, 2-bit down counter with negative age triggering, right? 2-bit down counter with negative age triggering. So here it is, my T flip-flop. T flip-flops are basically or internally JK flip-flop where J and K is connected to logic 1, right? This is my Q, Q complement, right? In down counting, you apply Q complement, you apply Q complement as a clock signal. Sorry. You apply Q complement as a clock signal to next, and you take output from this, right? So what basically is there that we'll see. So initially it is 0, 0, right? Initially it is 0, 0. When you apply clock pulse, first clock pulse is applied, then it is 0 toggle to 1, right? So here it is 1. So right, F1 is 0. Sorry, F1 is 1. But at initial movement, when it is 0, that means this is also 0 initially. And if Q is initially 0, that means what is Q complement? Q complement is 1 initially. So this is also directly applied to this as clock signal, and it converts from 0 to 1, right? So this is how it becomes 1, right? Now next, if uh, when you apply the next clock pulse, now this becomes 0 to 1 at first clock pulse. If it becomes 0 to 1, Q complement will be 1 to 0. So this is about first clock cycle. When you apply second clock cycle, it becomes 1 to 0, right? And this becomes 1 to 0. Q complement is 0 initially. So it keeps as it is, right? It keeps as it is. When it becomes 0 at second, it will change to 1, right? So in second clock cycle, it will change to 1, 0 and 0, right? So this is how you, what you say, you call or you count in downward direction. Basically, you need to use a reverse order to get your exact count, right? This is 1, 1, this is 1, 0, this is 0, 1, and this is 0, 0, right? This is how you, you need to treat this counting, right? So this is basically called a down counting in case of negative age triggering. And in case of positive age triggering, for down counting, you need to connect Q to clock pulse, right? In case of positive age triggering, right? So this is how you can have your synchronous and asynchronous counter of 2 bit in positive and negative. कळलं का हे? हे कळलं का? Now we'll see now we'll see 2 bit up down ripple counter with negative edge triggering, right? With negative edge triggering. So this is my first flip flop. Second flip flop. A1, A1, 2 complement 1 is 0, A0, Q0 complement 0, right? A3 is connect. Need to connect to logic 1 for toggling, right? In case of up-down counting, you need to connect this and this both the things to clock, right? So this is initial clock. I need to connect this and Q complement to this. That means what I require is I require OR gate there. Right? How OR gate is connected based on right? Based on mode. So my mode is going to decide what to. So my mode is going to decide it is up counting or down counting. How? If Q and this is handed properly, it is up counted, Q complement and this mode is handed properly, then this is what is down counting, right? So how it will start if it is equal to 1, that means it becomes 0. In that case, this is inactive, right? This is active. So whatever value are coming over there will directly pass to second flip flop or flip flop 0, right? If my mode changes from 1 to 0, it becomes 1 and this is active. In that case, this AND gate is inactive and this is called down counting, right? So up counting is when mode equal to 1 and down counting when mode is equal to 0. We'll start counting in downward direction. This is how it looks like, right? And what is in negative age triggering? In negative age triggering, you need to, positive age triggering, you need to change a clock signal symbol there from JK flip flops and you need to change a direction. You need to apply not get to this direction. So if m equal to 0, it is up counting. When m equal to 1, it is down counting, right? This is there in positive ways trigger. And diagram which is there in red flip flops are there, that is called a negative ways triggering up down counter, right? हे समजलं का? हे समजलं का? अप डाऊन काउंटर कसा आहे? ओके.
हॅलो सर.
हा
सर ते एकदा डबल एक्सप्लेन करता का सर? ते वरचं एक्स एम इज इक्वल टू म्हणजे ते आपण जे नॉट गेट वापरले सर्वर ते त्याचा रोल डबल एकदा पुन्हा.
हे जर मोड 1 असेल ना तर 1 म्हणजे इकडं 1 येतं आणि हे 0, राईट? या केस मध्ये याच्या ज्या व्हॅल्यूज आहेत ते ऑल द टाइम 0 राहतात, राईट? ऑल द टाइम इट बिकम्स 0. वाय? कारण हे इथं 0च आहे. तो या केस मध्ये ह्या चेंज होत नाहीत. इथल्या व्हॅल्यू काय चेंज होतात कधी क्लॉक पल्स अप्लाय करायचं ते. आता हे 1 आहे ना, या केस मध्ये इथं जर 1 आलं नाही तर 1 into 1 is 1, right? 1 or 0 always, right? 1 or 0 म्हणजे इथं क्लॉक पल्स अप्लाय होणार. सो या हे जे आहे ना, इफ मोड इक्वल टू 1 असेल ना, या केस मध्ये हे अँड गेट ऍक्टिव्ह असतं अँड व्हॅल्यूज आर टोटली डिपेंड्स ऑन क्यू, राईट? म्हणजे क्यू 0 असेल तर हे 0 पास होणार, क्लॉक पल्स अप्लाय नाही होणार. क्यू 1 असेल तर त्या केसमध्ये 1 into 1 आणि 1 पास होणार आणि हे अप्लाय होणार. बट वेर आज या केसमध्ये हे कंटिन्यू 0 राहतं. सो 0 into एनिथिंग इज 0. त्यामुळे कधीही तुमची क्लॉक पल्स अप्लाय होणार नाही ज्या केसमध्ये मोड 1 असतो, राईट? सो हे 0च राहील. वेन यू कन्वर्ट वेन यू चेंज युअर सिग्नल फ्रॉम 1 to 0, हे 0 राहील. म्हणजे इथं 0 होईल. सो 0 into एनिथिंग, हे काही जरी असेल तर हे ऑल द टाइम दिस इज 0. बट when it is 0, it inverted into 1 by this not gate. म्हणजे इथं 1 आता अप्लाय झाला, राईट? सो इथं 1 आहे. सो व्हॉट एव्हर इज द व्हॅल्यू ऑफ Q1, म्हणजे हा 1 असेल तर इकडं चेंज होणार आणि हा 1 होणार. इथं 0 असेल तर क्लॉक पल्स नाही अप्लाय, राईट? सो या वेनी डायरेक्टली म्हणजे अप काउंटिंगच्या केसमध्ये मोड 1 असतो आणि डाऊन काउंटिंगच्या केसमध्ये मोड 0 असतो, राईट? सो मोड 0 असेल तर हे जे काउंटर अरेंजमेंट आहे ते डाऊन काउंटिंग करत असेल आणि मोड 1 असेल तर त्या केसमध्ये अप काउंटिंग चालू असेल, राईट? सो असं बेसिकली हे असतं अरेंजमेंट असते. आणि यातलं एक कंटिन्युअस 0 असतो, त्यामुळे इथं काही असेल तरी अप्लाय होत नाही. आणि इथं जर 1 असेल तर त्या केसमध्ये इथं जर 1 असेल तर त्या केसमध्ये जी काही व्हॅल्यू आहे क्यू कॉम्प्लिमेंटची ती डायरेक्टली अप्लाय होते. कळलं का विचार?
येस सर, कळालं सर.
ओके. अजून कुणाला काही प्रॉब्लेम आहे का? बाकीच्यांना कळलंय का अजून? ओके ओके, पुढे जाऊयात का आता? Okay, so this is about, up down counting, right? We'll see, we already gone through 2-bit up counter, down counter, up down counter. Now, what is addition there? It becomes either 3-bit or 4-bit, right? But the arrangement is same, right? Arrangement in asynchronous is same. म्हणजे काय तर 2-bit असेल तर त्या केसमध्ये 2 असतात 3 बिट असेल तर 3 असणार आहेत. मग त्या केसमध्ये अप काउंटिंग असेल तर क्यू कनेक्ट करायचा दुसऱ्या फ्लिप फ्लॉपला आणि डाऊन काउंटिंग असेल त्या केसमध्ये 3 बिट. इन दॅट केस क्यू कॉम्प्लिमेंट नीड टू अप्लाइड ॲज अ क्लॉक सिग्नल टू नेक्स्ट फ्लिप फ्लॉप राईट. बीट वाढले परत 4 बीट असेल तरी अरेंजमेंट सेमच राहते राईट. दिस इज हाऊ बीटचा रादर डिफरन्स नाही पडणार आहे. बीट जितके रादर फ्लिप फ्लॉप जितके असतील अरेंजमेंट सेम राईट. नाव विल सी mod 6 counter. Okay, mod 6 counter. Now what is modulus of counter? What is modulus of counter? What is modulus of counter? Yes, the state from which counter goes. Right. So या केस मध्ये मॉड 6 असेल तर 3 व्हेरिएबल लागणार आहेत. दॅट मीन्स 3 फ्लिप फ्लॉप लागणार आहेत. 0 0 0 0 0 1 0 1 0 0 1 1 1 0 1 0 1 1 1 0 1 1 1. राईट. सो हा हा काउंटर इथपर्यंत काउंट करेल. राईट. यांनी काय करायचं हे आलं की 0 डायरेक्टली व्हायला पाहिजे. राईट. ही स्टेज आले की इट विल start counting again from 0. But what is the problem? Since we are using 3 flip-flop, it will count from 0 0 0 to 1 1 1. राईट. जर आपण 3 फ्लिप-फ्लॉपची अरेंजमेंट करत असेल त्या केसमध्ये हे इतकं काउंट करणारच. सो what you need to do when sorry when it comes to this stage, no, ज्यावेळेस ते या स्टेजला येईल डिरेक्टली काय करायचंय तुम्हाला 0 करायचं. राईट. when it comes to this stage you need to clear all flip flop and make it as 0 0 0. That is basically addition in this modulus of counter. That means you are start counting from 0 and you are going to stop your counter here only and not going to count this, which is basically a normal behavior of 3-bit counter, right? So mod 6 counter in this the two cases is apply logic 1 to this clock signal directly applied here. Q2 Q1 0. That is basically start counting from 0, 1, 1. Right? So what when it becomes when my outputs are 1, 1, 0, it should outputs are this AND gate. When AND gate is active, when the inputs are at 1, 1, 1, right? So this is 1, this is 1, but this is basically 0. So you need to connect NOT gate to this. So here till here it is 0, then it becomes 1. When 1, 1, 1 is there, this is active and signal is passed to all flip. In that case, you need to apply this to clear input of flip flops, right? So when it becomes 1, 1, 0, this output is passed to this AND gate, and AND gate will again pass a signal to all clear input, and all the flip flop becomes 0, 0, 0 at that point, right? And it will stop counting on that date and again start from 0, right? So when it is 1, 1, 0, it will start the stop counting at that moment, and it will clear out all the flip flops which are there, and it becomes 0, 0, 0 at that stage, right? So this is basically called a mod 6 counter or modulus of count, right? What is your homework is you need to draw or you need to design a mod 10 counter, right? Mod 10 counter design करायचं उद्या मला सांगायचं की त्याचे इनपुट्स वगैरे काय असतील, right? This is all basically about the synchronous count.